right, should be a really interesting design day today because we're going to be working on the chassis. So since the last video, a few things happened. I added these bump stops to the front suspension, and it's this really cool slapper arm design. And the idea behind these is that as the lower control arm cycles up and down, the bump stop is tied to this little arm here that keeps its pivot point in the right place, so that when the upper control arm cycles all the way up, this arm is always in contact with it, and it allows the bump stops to pivot with the rest of the suspension assembly, which is pretty cool. On the back bump stops, I just have a traditional design where the bump stop cylinder is fixed in place to the chassis, and then this round cup down here slides across the trailing arm as it cycles up and down. So for the chassis design, I'm referencing this rock bouncer cage from a builder called Angry Fab Designs. I think it's really cool looking the way that all these tubes are curved and there's no straight edges. And I also like that the seats are leaned way far back. So as the design stands right now, there's still enough clearance for the driver to be able to see over all this suspension components. But I think I might raise these chairs a little bit, because if you look at it from the front, that spare tire is protruding pretty high up, and I can't really tuck that away any lower without compromising departure angle, which is right now that departure angle is about 50 degrees. I wouldn't want to go much lower than 45 degrees. So I'll probably keep that spare tire where it is and just make the cage a little bit taller, maybe add a roof rack on top, see how it looks, see whether or not I want to end up raising those seats or tilting them forward a little bit. I want to keep the center of gravity pretty low, which right now the center of gravity is kind of in the perfect spot. It's right here in between the two rear passenger seats, and it's behind the pivot point for the trailing arms. So I will have good anti-squat on this under power. And I'm assuming that the cage is going to be homogeneous in its mass, meaning that it's not going to be heavily biased front or rear. It's just going to be another part that has a CG that's roughly the same as the vehicle. And so far this assembly weighs 7,000 pounds without the cage. So it's going to be a heavy vehicle. Most of that weight is honestly the tires. I'm using billet aluminum everywhere I can. These are accurate models for the seats and the people and the weight and the motor as well. I was really careful during this design to make sure that I had all the material properties correct on every component that I input, to make sure I can have an accurate CG calculation and total weight at the end. So time to lock in and start working on that frame. So I'm referencing a design from Angry Fab, which is a rock bouncer builder. And what I really like about those designs is there's a lot of curves and there's no straight lines on the profile of the vehicle. So that's what I'm going to try to emulate. And I'm starting with this subassembly for the chassis, which contains all of the mounting points for the hardware for the suspension, and then making that first arc around the driver and the passenger. And so what I'm ultimately going to end up doing is a 3D sketch. But first I want to start with a side profile sketch so that I can reference the 3D sketch off of that and keep as many components of the sketch constrained as possible. So the important thing for this design is that it's sort of egg-shaped, because a sphere is the strongest shape in any given direction. And if I have curves all over the place encapsulating the cabin and tying the suspension components together, it will be strong anytime it rolls in any direction. And it also makes it look really cool. So once I have those top arcs, I can define the side arcs to encapsulate the envelope of the cabin on the lateral side. And I just have these big sweeping lines all interconnected in places that make sense so that the point loads all intersect. The other thing that I'm being really careful about is that each of the curves are different radiuses, but they're all round numbers in inches, and anywhere possible I try to make them round up to the nearest foot. And the reason for that is when I'm bending these tubes, I don't want any weird fractional bend radiuses. I want all the bend radiuses to be as close as possible to a nearest foot so that the fabrication can be a lot easier. And so I'm interconnecting all these arcs in a way that makes sense, where they're sort of tangent to each other where they can, and trying to avoid compound radiuses wherever I can. so that each piece that's cut is just one radius throughout, and then you only have to worry about the length of that piece and then the coping in between the interconnects. So this part on the back ended up being kind of tricky because I needed to capture that rod end that provides the pivot point for the spare tire, but also leave enough room for the spare tire to swing down. And the back part of the assembly can be fairly light in terms of structure because there's not a lot of force back there. The trailing arms on the rear suspension push into the shocks, which push into the part of the chassis right behind the passenger. So really the only thing the rear of the chassis has to do is hold up the weight of that tire and the fuel cell. And so I'm keeping the front and rear of the chassis fairly simple. And then I'm trying to define the floor pan of the vehicle so that I have enough room for the cabin and the footwell, and also make sure that it's not going to interfere with the tire as it's turning and cycling through travel. So I ended up going with this double arc where the driver row of seats has one arc and then the passenger row of seats has another set of arcs. And then those can tie into the side profile of the chassis a lot easier. So this part is the torsion bar, and that torsion bar is nested inside of one of the tubes on the chassis. So this is one of the first parts that I can build in is just a simple tube that's extruded outward that captures that torsion bar. And same thing goes for the spare tire mount. I have those weld nuts on the end that capture a tube, and those bolt to the rod ends that allow for the pivot point of the spare tire. And I have an axis defining that pivot point for the spare tire, and then I'm mating the sketch to that axis. So now I'm making some planes that are going to locate the mounting points for the trailing arm. And what I'm doing is making a simple boss that goes out from that plane and then a cut on that same plane to make two plates that will capture either side of the spherical bearing on the pivot point for the trailing arm. And once I have these in, I'll have a good idea of where the chassis needs to be extra strong in order to take the load from the trailing arm, which is going to have the most load out of any of the suspension components. And now I'm doing the same thing for the upper radius links that constrain the rear wheel suspension. I have a boss and then a cut to make those two plates where the rear trailing links are going to attach to. And then I'll build the chassis around these plates. Same thing for the shock mounts here. And these shock mounts are going to tie into the top part of the chassis. And it's going to be the most prominent sheet metal work on the whole thing. And so now I'm working on some anchor points in the 3D sketch that are going to tie into those mounting plates on the chassis. So these are construction geometry lines that I'm going to anchor the points on the 3D sketch to, and then build everything around it as close as possible to that side profile sketch. This plate is for the rear bump stop, trying to constrain it as much as possible, even though it's kind of a strange shape. And then same thing, a boss and then a cut that shares the same sketch. And so now I need to make the two front extrusions that are going to go through that front chassis bulkhead. But before that, I need to make some mounting plates for the front bump stops that tie into that front bulkhead. And so I'm modifying the bulkhead part to have some extra plates that will tie the chassis to the front bump stops. And then I just need to add some lightweighting cuts. My favorite SolidWorks feature to use for lightweighting cuts is offset entities with trim entities. So you can have a center sketch and then offset entities around that, which creates a sketch that's offset by a distance that you define. And then everything that's left over, you can just trim that out so that you have a fully defined sketch that you can boss, extrude in one feature. And if these share the same center plane, then they can share the same sketch with a mid-plane boss and a mid-plane cut. And so this part ended up looking really cool. It's going to be really strong. And I just want another chassis beam going right through the center of it to constrain it laterally. And then that first arc that I'm defining, I need to make sure that it can capture the winch in a place that's going to have good approach angle. And it's the front of the vehicle, so it has to sort of have a cool shape to it as well. So now I can make some anchor points for the first arc of the 3D sketch. And the part is starting to take shape. So I need to make sure that there's room in the back for the suspension to cycle through without hitting any of the components. And I need to work around the engine, which is mid-mounted, which makes the geometry kind of tricky because I have to build an engine cage around the engine and the suspension components. And I want to retain that egg shape for strength. So same thing on these 3D sketches. I'm focusing more on the radiuses of those sketches and letting the points lie where they intersect in a way that makes sense. But if you decrease the radius of the curve, it gives you a little bit more room in the vehicle, which is what I'm doing on that floor pan here, and tying in the front dash to those rear suspension mounting points. These are the most important parts of the sketch because these are going to be the main structural load members on the chassis that tie the front bulkhead to the suspension components and encapsulate the driver. So they need to be really precise and really strong and curved in a way that leaves enough room for the cabin and also intersect with each other in a way where there's no bending forces on the rods and all the loads intersect at a common point at the weld. And initially, I was a little bit concerned about making all of these radiuses in 3D space and keeping them constrained. But what I found was that construction geometry is incredibly useful for this because you can define an arc in 3 points. And if you use a construction line that's defined along one of the axes of the sketch, it defines that arc as well, wherever it intersects. So even though the arc is making some really strange trajectory through space, the construction lines sort of keep everything tied in together and keep everything constrained, because what you want to avoid is a bunch of those blue lines in the 3D sketch, because then if you move one thing, it moves everything. But if all of these lines are independent of each other, defined on their own arcs, then it really makes things a lot easier. So another trick that I learned once I got even just a little bit into this design is that the way that the smart dimensions present themselves in the 3D sketch is that you have all these crazy leaders going all over the place, especially on the radiuses. Like you'll have a line going all the way out to the center of the arc. So what I do is on the line properties and the dimension properties, you can change the leader type up in the top left to make those dimensions root off of the edge of the curve rather than through the center of the arc. And it just makes things visually a lot easier to manage, because this part's going to get really complicated with all these curves on this 3D sketch. And I need to make sure that I'm tracking where the actual lines are, where the tubes will go, and not getting lost in the sauce of the smart dimensions. So now I'm trying to figure out where that front windshield arc is going to live. And I want to make sure that it's not going to obstruct the view of the driver. Most trophy trucks have an arc that goes from the center of the bulkhead to the top of the roll cage at a slight angle. There's 2 of them. And I'm trying to achieve something similar here while also leaving room for the driver to look straight through the vehicle in a way that's unobstructed. Now I need to start figuring out how to tie in the rear of the chassis. And I left that side profile sketch pretty blank back there because there's just a ton of components that I need to get around, like the engine, and I need to figure out where the fuel tank is going to live. You can see that exhaust is sort of in the way. I ended up changing that design to make room for the fuel tank, and I need to figure out how to tie in these rear bump stops as well. So the rear of the chassis ended up being the most complicated because it didn't follow a specific shape. It was just playing connect the dots with the points on the chassis and leaving clearance for all the components that are stuffed back there in the mid-engine configuration, which makes it sort of challenging. So now I need to figure out how to tie in the rear spare tire mount in a way that makes sure that it's strong enough to carry the load of that 300-pound tire and wheel combination, as well as leave clearance for it to swing down without crashing into the chassis. So I ended up going with a cantilever design because when the vehicle's moving, the majority of the weight of the wheel is going to be resting on the rear of the chassis and not that cantilever. The cantilever is only constraining it in the longitudinal direction, and the force load from the spare tire will be just bouncing up and down on the back of the chassis, which there's plenty of room for lots of tube work back there. And so I'm using X bracing and straight lines here to make this because this is not a prominent aspect of the chassis. You won't be able to see this very much when the tire is in its tilted up position. And when the tire is resting on the chassis, it's on a flat plane. So I want to use flat lines and straight edges. And I just need to tie that trellis X-frame into the center bottom tube of the chassis and create a little box for the rear winch to go in, because the rear winch is essential for tilting that spare tire down. So the idea is you would loop the winch cable around the back of the tire and then pull it over and around that arc to get it down, rather than using 300-pound gas struts or something crazy like that. So the rear of that chassis is starting to take shape. I just need to make sure there's enough clearance for everything, especially for the suspension to cycle through and the rear tire. And again, that exhaust that you see there poking through, that's going to get changed. And so there's my first arc back there. Yeah, that exhaust is no longer going to be going through the center of the spare tire. So this is the cradle, so to speak, for the rear spare tire to mount to. It's just going to rest on this trellis back here. And I'm just making sure that I have lots of room for the suspension components to cycle through. And so what I like to do is open up the upper assembly, isolate the components that I'm checking, and then take a look at that 3D sketch in reference to those components. So I spent a lot of time during this part of the process going back and forth between the part edit and the upper assembly, checking clearances and checking sketches and modifying things here and there. But I actually ran into an issue with references in SolidWorks. So since I have an upper assembly and a chassis assembly, I wasn't careful about where I was referencing things in the sketch. So the part file was referencing both the upper assembly and the chassis assembly, and SolidWorks didn't like that. So I ended up deleting all of the references from the upper assembly and only using references from the chassis assembly. And that made things a lot simpler, and I didn't have any rebuild errors in the SolidWorks part. So now I'm defining that top arc of the chassis, and this is really exciting because everything from here on out is just filling in the gaps and connecting the dots and making sure my force point loads are all connected to each other, and I can start adding some tube work. So I have 3 different types of tubes in here. The first is 2.5 inch diameter 4130 with 1/4 inch wall thickness, which is about as big as it gets in the rock bouncer world. I don't think anyone goes bigger than that. It's pretty overkill for most applications, but I'm only using this in a few places, basically the bottom center tube for the chassis, and then everything that ties the bulkhead to each other. There's a few arcs on the chassis that use that 250 wall, 2.5 inch tube, but I wanted to keep this relatively light, so I didn't use it everywhere. So that's the first type of tube that I'm defining. And so what I'm doing is I have a chassis master sketch, which is that 3D sketch, and then I'm going to have 3 different types of structural weldment features in this part to define those 3 different tube types. And so this 250 wall goes from front to back in the bottom center, and then everywhere on the floor pan, and then a few places along the top arc of the vehicle. And so that's what I'm doing here. I'm starting to add the tubes in, and the chassis is starting to take shape after I got through that somewhat challenging aspect of the design, which was making the master 3D sketch. So what I end up doing is making the 250 wall tubes, and then going back to the sketch and modifying things where I need to, and then adding more tubes and then modifying the sketch again. And then that iterative process lets the part take shape in a way that you don't have to walk anything back too far if you make a mistake. It's all still editable, and you just build the aspects of the chassis piece by piece, starting with the most important structural components. So just checking my suspension clearances here. And I have this one tube going around the shocks, which I wasn't planning on that, but it ended up presenting itself in the design, and it ended up making sense. So like if the vehicle rolls over on its side, those shocks are super exposed because besides the tires, they're the things that stick out the furthest. And so having a tube around that really helps protect those critical components. Because if you hit a shock on the side, it's just going to buckle immediately. The shocks are only strong along the axis of their articulation. And so now I'm making the second type of 4130 tube size, which is defined by the tube that I used to capture the torsion bar, which is 2 inch diameter with a 120 wall thickness. And so this is half the weight of the first set of tubes that I built in. And this is going to be the majority of the chassis. And then the third type of tube that I use is 1.75 inch with a 120 wall again. And this is defined by the rod ends that I chose for the spare tire cage. And those have a specific weld nut that they are designed for. And so the rear of the vehicle, the only thing it's holding up is the spare tire and the fuel tank. That's where I'm using the lightest tubes. It's the same tubes that I used on the spare tire cage. And so I'm sort of rebalancing the weight of the vehicle because the heaviest chassis material is in the front and most of the tube work is in the front. And then the back, everything after the shock mount points can be super light. So now that I have those 3 different types of tubes in the assembly, I can start filling in some of the missing details on the rest of the chassis. So adding in the final structural components and really making the thing rigid. So I wanted it to be strong, not only in a rollover, but
also very rigid in torsion around the longitudinal axis of the frame. Torsional rigidity seems to be key for car performance. And if you have too much chassis flex, it can cause binding between components that are undesired. So I'm just adding in more and more arcs wherever I can to flesh out the roof and still continuing to make sure that all the dimensions are easy to fabricate. This part right here, the shock mount, needs to be kind of a funky shape to interface with all the different tubes, but ultimately ended up looking pretty cool, which I'm happy about because, again, it's the most prominent piece that's fabricated on the chassis is the shock mounts, and a lot of people try to make those look as cool as possible. So I'm adding in the rest of those 2-inch tubes here to tie in the suspension components to the broader chassis. And this part here with the upper radius link mount was kind of tricky because it's really wide to make room for the rod ends that I use. So I'd have two tubes that were pretty close to each other, but not quite parallel because one is curved and one is not. But I think it ended up being the right shape. And then back here, I need to make sure that the torsion bar is fully constrained in all 3 directions because it's going to have a bunch of weird loads on it. It's not going to have necessarily a force load on that tube in the direction of the suspension, but what it is going to have is a twisting moment as the torsion bar fights the sway bar arms. So again, with sway bars, as one part of the vehicle rolls, it tries to push the other side of the vehicle down. So it keeps the vehicle flat as you're going through a turn or articulating over rocks. And so I'm hiding those straight cuts with some more curves to make it look a little bit cooler and follow the arc of the roof because that roof line has a curve to it. And so all those forces are going to be pushed back down into the back of the chassis in a rollover. And the more tangent they are to each other, the stronger they're going to be. And now I'm adding some more beams to capture the shock mounts to constrain them laterally and vertically because the entire weight of the vehicle is going to be supported by this plate. And so it needs to be tied into the frame in a really secure way. So I'm just making some lightweighting cuts here to make this part look a little bit more designed than it is. I don't know a ton about chassis design. Basically what I'm doing on this is just following force loads throughout the chassis and making sure that there's no points where a force load reaches a dead end or intersects with a beam that's going to have a bending moment on it. And there's really great videos out there from Morgan Clark Design explaining tube chassis development and his thought process for how to fabricate something that is artistically beautiful, but also incredibly strong. And I really take a lot of design inspiration from some of his builds because there's nothing else like that out there. And Morgan Clark is obviously just a master at what he does when it comes to vehicle design, and tube work specifically was what I'm most inspired by. He has some really cool organic shapes and curves and radiuses, and it just really turns the chassis into a piece of art rather than just a bunch of boxes that hold everything together. So that's what I'm trying to mimic here in this design. So a part like this with all these compound radiuses and weird angles and strange lengths, the coping on this to get the tubes to interface with each other would be so complex that I really only imagine something like this being CNC cut and bent, which that's becoming more and more common these days, where you have a CNC tube bender with a laser cutter at the end, where you can, if you define the profile of the cut correctly, you can just snap parts together and they just fit perfectly first try. And there's not a lot of cutting and grinding and measuring and double checking like traditional fabrication. If you spend the right amount of time on the CAD model, it can really make things a lot easier when it comes to fabrication if you have access to those CNC tube benders and laser cutters. So that's sort of what I'm counting on for this design. And one of the issues with SolidWorks is it's not really good at defining the coping in between pipes. So I really want to send this to someone like TubeWorks in order to get this designed properly. So what I just did here was I mirrored the part around the right plane. In the past, when I've done SolidWorks Weldment tube chassis, if I try to mirror sketches from side to side, it just becomes too messy. It becomes over constrained and you start chasing your tail when you try to edit things. So I find the best way to do it is make one shell of the tube and then mirror that part to the other side. And if you mirror the bodies, it's really simple and it's not going to break any features. And so that's why something like this, I would want to export this tube file as a step and then send that to the guys at TubeWorks, for example, and have them review the design and make sure everything looks correct. And then they would probably end up rebuilding it with all the right coping and joints around the tube interfaces so that everything can be CNC cut. And then each part would have a unique file name, and then you could cut and demarcate those tubes and slap them together in a fixture and then tack weld. But for this initial design, it's all just one part because I want to make sure that the shape is correct. And I have a lot of moving components in here with the suspension, especially because it's front independent suspension and rear independent suspension, which is not super common. There's only a few designs out there like this. So it's really complicated. And to get everything to cycle properly on the suspension and not interface with the tubes, it made the most sense to me to just make one big part file for the entire tube chassis and then iterate off of it. So now I'm just checking all my suspension, making sure everything clears, and it's starting to look pretty done.